Okay, let's try out an example. You probably want to have your formula sheet with you just so that you can reference it as we're working through. Okay, so if we take a look here, we have y prime minus 3y is equal to this delta function centered at 2. And we know that our initial condition, y at 0 equals 0. So we are starting off like chilling. We see that when we start off, our derivative is just proportional to our value. And so we're just going to be equal to 0 for a little bit. Let's see what happens when we hit our system with a hammer at time 2. Okay. So we're going to start off by taking the Laplace transform of its sides. Let's try that out. On the left-hand side, we have s times the Laplace transform of little y is big Y, minus little y at 0, minus 3 times the Laplace transform of little y, or big Y. This is going to be equal to the Laplace transform of delta 2 of t, which is e to the negative 2s, just a bare exponential. Okay. We include our initial condition, which was just equal to 0. So this gives us that s minus 3 times y equals e to the negative 2s. And we can solve for y. Y is e to the negative 2s times 1 over s minus 3. All right, so we found the Laplace transform of our solution. We just need to go back. We're going to be using that the inverse Laplace transform of e to the negative as times f of s is equal to ua of t times f of t minus a. So shifted right by a. In our case, a equals 2. Notice there's already a negative sign in our expression here. And our f of s was equal to 1 over s minus 3. All right, so we are going to take the inverse Laplace transform of 1 over s minus 3. And we get e to the 3t. Okay. So y of t then is going to be u2 of t. So that's coming from our a value. And then we're going to take our f of t, which it was this inverse Laplace transform of 1 over s minus 3. And we're going to shift it to the right by 2. So every time we see a t, we're going to write t minus 2. Okie dokie. And so this is our function. If we want to think about the graph of this function, which is nice if we're thinking about solutions. So it's going to be equal to 0. Let's make this a little chunkier. It's going to be equal to 0 until time 2, at which point it's going to look like e to the 3t minus 2. So when t is equal to 2, that gives us e to the 3 times 0, so e to the 0. So then it's going to jump up to being a value of 1. And now it's growing like an exponential. All right. Great. So, and that kind of makes sense. So like we were starting off with nothing really going on. So our initial condition was 0. If we didn't have that delta 2 of t term here, we know that, let's just take a look at this related expression, y prime minus 3y equals 0, or y prime equals 3y. Right, we've looked at the phase line for this guy before. We've got an equilibrium here at 0, and then this guy is unstable. So once we get knocked off of that equilibrium, all of a sudden we're going to have exponential growth. Okay. All righty. Great. Okay, on to the next one.